Okay, number 8. We want to list the intercepts and test for symmetry. Okay, this time, since we have our graph in terms of y equal, I want to show you the function notation. It can probably be confusing, so if you don't like it, you can continue just to make y negative, make x negative, and solve. But I implore you to try to learn both, because you never know what you will see later on. And I'll try to do both of them here. It just take a little bit more time. So let's do the intercepts first and show you the difference. Let's do the intercepts first. So y intercept, x is 0. That means we would have ordered pair 0, comma something. So we would have y equals, if we plug a 0 for x on the top, we would end up with 0. If I get 0 on the top, it doesn't matter what's on the bottom, but it would just end up being 81. And 0 divided by any number is still 0. So our y-intercept is 0, 0. Now our x-intercept. This time y is 0. So we have a 0 equals 7x divided by x squared plus 81. Okay, so what we would do to get rid of this fraction is multiply by what's on the bottom. So I'd have to multiply x squared plus 81 on both sides. Alright, so when I multiply on this side, it just divides out. Over here, 0 times anything is 0. So you end up with 0 equals 7x. When you divide by 7, similar situation, any number, 0 divided by any number is still 0. So we get x equals 0. And the ordered pair, since y is 0 and x is 0, we get 0, 0. So I get the same ordered pair. So there's one intercept. It crosses the x and the y. It is 0, 0, the origin. So our intercept is 0, in parentheses, 0, comma 0. Okay. Now we want to do symmetry. Okay, so let me do it with function notation first. So remember, y is equal to f of x. I'm going to show you what this looks like. Y is equal to f of x. Alright, so my function, when I write it in function notation, is this. F of x, which is y, equals 7x divided by x squared plus 81. Alright, now there were 3 forms that we looked at. Let me come over here and show you. There was f of x, the original, the negative f of x, which is on the outside, and then the f of negative x, which is on the inside. That's basically what we're looking at. And then the last one compared these 2 forms to each other. The negative on the outside, negative on the inside. So really, once we do these 2, we will get this third one for free. So I have my original f of x. Alright. So now negative f of x, like this, just means you're going to plug a negative on the outside. You can look and see that these 2 are not the same. Okay, this one has a negative, this one does not. Okay, so if we were comparing those, we can see that it does not have y or x-axis symmetry. That would be the definition for x-axis. Now there's one more we need to do, f of negative x. So this time we're plugging the negative on the x. So that means 7 negative x and then negative x squared plus 81. When we simplify this, that will still be a negative, 7x. And then on the bottom, this x squared, this negative x will become squared and be a positive x squared. And this will give us positive 81. Okay. This does not match this. Okay. So, when I compare my original function to making y negative, they don't match. So that is, let me go back to the definition. That is this first case. You compare f of x to the negative f of x. That's x-axis symmetry. Compare f of x to the negative f of x. That's x-axis. So these don't match, so no x-axis. The next case was compare the original to the f of negative x. See if these two are the same. Alright, so that is this one compared to this one. They are not the same because of that negative out front. So this does not have y-axis. They don't match. The last one compares the bottom two, see if they are the same. So when I change y negative and x negative, this graph and this graph are the same. So this would have origin symmetry. So it does have origin. Okay, so I wrote origin, which you can't see. Alright, now that was probably tough, but with a little practice you can get it. Now I also want to do it the other way, just making x negative, making y negative, just so you can see it that way as well. Okay, but I like using this form. It simplifies the work once you understand it, but if you have questions, just please ask. Alright, so let's go back to the other way, but many of you might like that way better. It may be less confusing, less symbols to deal with. Y equals 7x divided by x squared plus 81. Alright, so x-axis. X-axis says make the y value negative. See if we get the same thing. Alright, so I'm going to make y negative. So I'm going to have a negative y equals 7x over x squared plus 81. Now, for all intents and purposes, you never want to leave y negative. You always want to fix it. So in order to fix this, to make y positive, you need to multiply both sides of the equal sign by a negative 1. Negative 1. So when you do negative times a negative, this becomes a positive y. And then over here, when you multiply by negative, this side becomes negative. And just put that negative out front, on the top or bottom, not both. So this is what you get when you do the x-axis. It does not match. Okay, so no x-axis. Alright, now we're going to do y-axis. Y-axis, remember, we're going to change the x value negative this time. Always the opposite. So that would be y equals 7 times negative x over negative x squared plus 81. Alright, similarly, we would get a negative 7x over positive x squared plus 81. Alright, you can see that this also does not match what we started with. Okay, this is positive. This one is negative. So no y-axis. Okay, now origin changes both. You take your x and y value, you're going to make them both negative. Alright, so that means a negative y over here, and then you have 7 times negative x over negative x quantity squared plus 81. So when you solve this, we get a negative y equals a negative 7x over x squared plus 81. So at first glance it doesn't look like it matches, but remember, we're not supposed to leave y negative. So we make this positive by multiplying by negative 1 on both sides. And when you multiply by negative 1, this becomes positive y. When you multiply by negative 1, that becomes a positive 7x. Okay, you don't multiply through on the top and bottom, just the top, or the bottom, but not both. And then that will give you x squared plus 81. I would just say just multiply on the top whenever you multiply by something. If you divide, it goes on the bottom. Alright, so this one does match what we originally started with, now that we fixed it completely. Okay, so again, origin symmetry. So both ways that we've looked at concluded with origin symmetry. Again, I like this one a little bit better. It's more compact, but you just got to remember those rules. Which one is comparing and knowing what? You compare original to this, and then these two. So this will be x-axis, y-axis, and then origin. Okay. So this one only has origin symmetry. So it says x-axis, no. Y-axis, no. Origin, yes.